Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Rindu Ryadivi and I will be presenting on determination of iron to content in groundwater using thiocyanate. Groundwater is an important natural resource that is abundantly available in many regions of the world and serves as a major source of drinking water for billions of people, supply water for household use, and maintains river and lake flow. It is estimated that nearly half of the global drinking water supply comes from groundwater. However, this research is often vulnerable to natural contamination from geological sources. Several reports have highlighted the high level of iron contamination in groundwater, especially in regions with iron-rich soil and aquifers. For instance, studies in areas such as Bangladesh and part of the United States have shown that up to 77% of groundwater samples exceed the World Health Organization guideline of 0.3 milligram per liter for iron, mainly due to geogenic factors. High level of iron in groundwater can give negative impact, including a metallic taste, reddish-brown discoloration, stain on laundry and plumbing fixtures, digestive problem, dry skin and clogging of pipe that can reduce water flow and damage infrastructure and ecosystem. Therefore, it is essential to measure iron 2 concentration in groundwater to assess its suitability for consumption, highlighting the importance of this study. To determine iron concentration in groundwater, both qualitative and quantitative analysis can be performed using the UV spectrophotometry method. In this research, the first step is preparing standard iron 2 solution at concentration of 0 ppm, 200 ppm, 400 ppm, and 600 ppm, which are derived from a 1000 ppm stock solution prepared in the laboratory. Each of these solution is then measured using a UV spectrophotometer with thiocyanate. The second step, 10 milliliters of groundwater sample was filtered and collected. Then 1 milliliter of sulfuric acid, 10 milliliters of 200 ppm iron 2 solution, and 5 milliliter of distilled water were added to the sample. The mixture was heated, and after 10 minutes, 10 drops of potassium permanganate were added. The pH was again adjusted to 2 to 3 using sodium hydroxide. After reaching the desired pH, 10 milliliters of potassium thiocyanate solution was added and the solution was transferred into a volumetric flask. Finally, the absorbance was measured using a UV spectrophotometer at a wavelength of 485 nanometer. The determination of iron to concentration was carried out based on a calibration curve constructed from standard solution with known iron to concentration. Linear regression of the data produced the calibration equation. The absorbance value of the sample was then applied to this equation, followed by calculation and correction for the addition of the 200 ppm iron to standard. From this process, the iron 2 concentration in the groundwater sample was obtained as 73 ppm. This result was then evaluated against water quality standard. The World Health Organization guideline for iron in drinking water is 0.3 milligram per liter or ppm, and the Indonesian national standard set a similar maximum limit. The detected concentration of 73 ppm is very high and exceeds the acceptable limit. Such a level indicates that the groundwater source is not suitable for consumption or direct domestic use without extensive treatment. That concludes my presentation. Thank you for your attention. See you next time, guys. Bye-bye.